Hello, welcome to part 6, in which we'll be looking at some methods to express voltages and powers in decibel terms. First thing to note is that a dB, as we've just seen, is the logarithm of a ratio, and therefore you cannot measure voltages or powers in dBs because voltage or a power is not a ratio. In order to express a voltage in dB terms, we have to express it as a ratio to another voltage or another power. But we can do that quite easily just by choosing a reference voltage or a reference power and expressing our voltage or power as a ratio to our reference voltage or power. For example, the first one. We can express powers in dBW. The W tells you what the reference power is. In this case, the reference power is 1 watt. So we take the power ratio of our power that we want to measure to the reference power of 1 watt, take the log of that multiplied by 10 because it's a power ratio, not a voltage ratio, and that would allow us to express this power in dB watts, this derived unit dB watts. We can do a similar thing with voltages and express any voltage in dBV by taking the ratio of our voltage to the reference of 1 volt, multiplying the logarithm of that by 20 because it's a voltage ratio, not a power ratio, and that gives us a method of expressing that voltage in dBV. We can also use different references. We can use a milliwatt, and that would give us our units of dBm. We can use 0.775 volts instead of 1 volt, and that would allow us to express voltages in dBu. The U means that the reference voltage that we're using is 0.775 volts. Why 0.775 volts, you might wonder? Well, there is a good reason, and the reason is that 0.775 volts corresponds to 1 milliwatt being dissipated across a 600 ohm resistor, and 600 ohms is a standard impedance in a lot of audio engineering situations. And it's audio engineers that tend to use the unit dBu. I'll do a few examples. How would you express the output of this amplifier in dBV? Well, there are two ways to do it. The first way to do it would be to take the gain, notice that gain is minus 20 dBs, and convert that gain into a voltage ratio, the voltage out divided by the voltage in. And we could do that by using the standard formula. V out over V in is 10 to the power of the gain in dBs, in this case minus 20 divided by 20, and that works out to be 0.1. So if we have a 0.4 volt source and we put it through an amplifier with a voltage gain of 0.1, then we would expect our output voltage to be 0.04 volts. Expressing that 0.04 volts in dBVs means just taking 20 log 10 of our voltage, 0.04, divided by the reference voltage, which for dBV means 1 volt. That gives us 20 log 10 of 0.04, and that works out to be about minus 28 dBs. Close enough. However, there's a quicker way. And the quicker way is the reason why we use these derived units in the first place. The quicker way is to do the calculation in dBs. Rather than taking everything out of dBs, working out the output voltage and then converting it back into dBs again. And doing it the quicker way means this. We take the 0.4 volts of the sine wave source and we convert that to dBVs. So that would give us 20 log 10 of 0.4 divided by the reference 1 volt. That gives us 20 times log 10 of 0.4 divided by 1, about minus 8 dBVs. So I have a minus 8 dBV signal here going into this amplifier. Working in dBs, since they're logarithmic units, a multiplication of the real voltages is equivalent to an addition of the log of the voltages. I take this minus 8 dBVs, in other words, and I can just add the effect of this gain to produce the output. I can say my input is minus 8 dBVs. The gain of this amplifier is minus 20 dBs. Therefore, my output is going to be minus 28 dBVs, which is a much easier calculation to do. And this works because decibels are logarithmic units. Effectively, what I'm doing is taking 20 log 10 of my input voltage, adding 20 log 10 of the gain of this amplifier, V out over V in. That's an addition of the minus 8 plus the minus 20. Well, that is 20 times log 10 of V in plus log 10 of V out over V in. And there's a very useful property of logarithms that says that the logarithm, put it here, the logarithm of x plus the logarithm of y is equal to the logarithm of x times y. So what I've got here is actually 20 times the logarithm of V in times V out over V in. The V ins cancel. 20 log 10 V out. But by definition, that is the output voltage expressed in dBVs. And it's much easier to do additions than it is to do multiplications, especially when you're having to do multiplications of large numbers or very small numbers. It's another case where working with dBs and these derived units of dBVs actually makes the maths a lot easier to work out. Okay, I think that's enough about dBs for now. Next time, we'll look at the rather less confusing subject of sine waves, phase, amplitude, and frequency, and how to add them up.